Hi, good morning everyone. Welcome to today's session. In this session we are going to discuss what is Fourier transform intuitively. The main agenda of this session is time is method of minimum two frequencies. We are going to see the meaning of this statement. Move from time domain to frequency domain. What is the idea of moving from time domain to frequency domain? Then finally the Fourier transform as a filter. Now look into this analog clock and just observe the statement below this. Time is continuous, but we measure in terms of rotation of second, minute and hour handles. Whatever be the time, we are measure it using a clock. Sometimes it may be digital, sometimes it may be some analog clock. In this session I am considering an analog clock to compare Fourier transform with the idea of analog clock. See, the time started at minus infinity and it will goes to plus infinity. Time is continuous and it will not be blocked by anything. Then how we measure time or how we represent time? Naturally we represent the time using the clock. How we can represent time using a clock? By this hour hand and also the minute hand, sometimes use second hand. These three hands represents the time. Then this hands moves, whatever be the shape of the dial, this minute hand and hour hand moves in circular path. Its locus is circle. So we just count the frequency. Based on the frequency of these two handles we measure the time. If some time is 11 o'clock or time is 11:15, in that case the minute hand is moves to this 3 and our hand moves to 11. That's all. Some point after 11. That's all. So we represent this notation with the help of these digits. Whatever be the time, we represent the time using, or we measure the time using the rotation of these handles. That is the idea. So the continuous time is measured in terms of the frequency of the movement of hour and minute handle. That means it is a combination of two frequencies, the frequency of the hour handle and also the frequency of the minute handle. So mathematically it can be denoted as f of t into e raised to I omega t. Here I denote e raised to minus I omega t. E raised to I omega t represents a circle. In complex form it is a circle. Here e raised to minus omega t means we moves in anti-clockwise direction. If we take e raised to plus I omega t, that represents a movement in clockwise direction. To understand this concept, I will use a simulation. In this simulation, we can see a wave move like this. It's a composite wave and it has different frequencies 1, 2, 3, 4 and 5 frequencies, and these different 5 frequencies are composite like this. Then we represent it in the form of a circle. To compare this particular simulation into our clock, I choose two frequencies, that is in 0 Hz and 1 Hz. Then this is the movement of minute handle in anti-clockwise direction. Actually in our clock we represent this in the clockwise direction. So this is the movement of time. It's like a sine wave. Similar is a sinusoid structure. Then that movement can be represented as a movement of a radial line along this circle in counterclockwise direction. It is clockwise direction. Sorry, it's counterclockwise direction. Then suppose we need one more handle, that means our handle. Put this one. Then we take the part. What are the different frequencies? See, one is our handle, other one is minute handle. Their frequencies are different. This our handle and minute handle moves in different frequencies. That is why we got the exact time. Then this is the different components of the time domain function. It has two components. When we take the total or the composite, it has two frequencies. one frequency corresponds to the minutes handle, another frequency corresponds to the hour handle. So actually we measure time using this circular approach. Whatever it is, we are using circular approach. But that in real life, the time is moving like that. From negative infinity to positive infinity, time moves like this, but we measure using this analog clock. It's interesting to see that the same thing, the same idea is extended to any wave, but certain characteristics should be satisfied. So a time domain is transferred into frequency domain. Even time measure is using this idea. Okay, then we move back to the other definitions and details of Fourier transform. What really Fourier transform do? Fourier transform simply transform a time domain function into frequency domain, nothing else. We are going to see this. So this slide shows you the continuous time domain is transformed into frequency domain with the help of an analog clock. Now the purpose of Fourier analysis is viewing any function in terms of frequencies. That's all. It is like split a dish into its ingredients or splitting a music composition into its components in terms of frequencies. What is the advantage of doing this? Suppose a dish is more salty, then we split it into different components or ingredients, then we decrease some salt element and we compose again the ingredients and get back the dish. If it is possible, it is very nice. We can do it with the help of Fourier transform. And also we split the music components into music composition into its components in terms of frequencies. Then we try to minimize the unwanted music or disturbance. Then we compose it again to the original composition. Then the noise reduction will happen. This noise reduction is an inline activity happen in advanced video players or Blu-ray players. So it is attained with the help of Fourier transform. Fourier transform is doing like this. We split it into different frequencies or we filtered the different frequencies. So the Fourier transform in our own life, hearing is the wonderful application of Fourier transform. In signal theory and analysis, we call it as Mel spectrum. In Mel spectrum, the sound is regenerated in our ear with the help of a Fourier transform. The lower frequencies will be vibrated in the initial stage of the cochlea, and the larger frequencies will vibrate to the end of the cochlea. So we can identify different frequencies and we can hear the music, hear different people talking, etc. Vision, the persistence of your vision can also be viewed in terms of Fourier transform. Decision making, we take decision based on the different frequencies of events. Unwanted frequencies will be eliminated and we take advantage of important frequencies. That is the idea of decision making. Perception, I am talking to you through this video, but you have your own experience and your own knowledge. Based on your knowledge, you judge this. I agree with you, I am not agreeing with this. Then you take the perception. The perception is actually also a filtering process. Then relationship, we have different types of relationship with people, different type of intimacy, different level of intimacy with people. It is purely based on some level of frequency and some level of amplitude. How frequent we are interact with a man or woman, automatically the relationship is strong. Then there is also the depth. The depth is actually incorporated in the amplitude. That's all. Everything in most of the things are viewed in through the lens of Fourier transform. Then the root map of Fourier theory. In this semester we will see the Fourier theory as a whole. In the last semester you have learned what is Fourier series expansion. It is nothing but express a periodic function with the Dirichlet's conditions as a discrete sum of sinusoids. Then in this module we are going to see how to express a non-periodic function as a sum of sinusoids. That means we are going to express a special category of functions, that means absolutely integrable functions as sum of sinusoids. That is actually Fourier integral representation. Start from periodic function, then go on to non-periodic function with the help of some minor conditions. But in signal theory, the signals are finite energy, satisfying the finite energy condition. Therefore, every signal can be represented as a Fourier series, Fourier transform. That is the idea. Then this Fourier integral will be generalized with the help of complex integration, and also complex representation of functions, and that is the idea of Fourier transform. That means we represent the time domain thing into frequency domain. Instead of measuring things on time domain, we are going to count the frequency. That idea is called the Fourier transform. So we gradually shift from the Fourier series to Fourier integral and then to Fourier transform. So the idea of Fourier transform is very useful for an engineer. So we will understand this idea with the help of lot of simulation, lot of problems, and lot of mathematical knowledge. These are the intuitive way of explaining Fourier transform. Mathematically, it involves some multiplication by exponential function, and we take the integration and lot of other operations, representation, manipulations, and some application of Riemann integration theory, etc. But whatever it is, in essence, Fourier transform is shifting from time domain to frequency domain. So we will see all the related topics in the next session. Thank you.